This is a quick run through of scientific method and experimental design. So when you're trying to go through the scientific process, what you should be doing, and how to make a better experiment than just an average experiment, we'll say. So step one, you gotta figure out the purpose of the experiment, like why are you doing it? So that would be asking a question. Just the who, what, when, where, why. That's really how you start the experiment. So, how does this affect blah, blah, blah? What would happen if we did this? Which would be better, this or this, etc. So, this creates a purpose for the experiment. So, then when you're finalizing your experiment, like, did you go back and answer the question? That's kind of like the purpose. Okay, step two is to create a hypothesis. So you've probably learned in your past that I usually make an if-then statement for a hypothesis. It doesn't always have to be an if-then statement in our class, but most likely yes. So if blah, 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 then this will happen because of this. So for example, if I change this in the experiment, then this will occur because of that. And the because is why you think that might happen. When you're done with the experiment and you've gotten your test results over many trials, you can go back to your hypothesis and you can either, we could talk about like rejecting and not rejecting and all that. That's later on when we do our more complicated labs. But for now, you can decide whether you want to change your hypothesis or you want to say that your hypothesis was proven. However, when you do that, though, you have to have like a significant amount of trials. Like anything at Fremd High School will not be enough, okay, for a proper laboratory experiment to be proven correct, we'll say. All right, step three, you test it by creating a procedure. Now, the procedure has to be very specific. Okay, so for example, the directions on the right side are describing a sample recipe. Okay, so this recipe tells us that we have to remove pots and pans from the oven that might be in there already. I find that really interesting because maybe people don't know to remove those from the oven before you heat the oven and put something in it. So basically, with a procedure, you only have one variable that changes. So a variable is something that is kept, a variable is something that we are testing that can change. So you only want one thing to be tested or measured. Does that make sense? So like all other variables should be kept unchanged or constant. We call this a controlled experiment. So your procedure should be detailed and discuss all parts of the experimental setup and how you will collect the data typically in science we do quantitative data, so numerical, or how is this thing going to be measured with a tool. However, there are qualitative ways to do it, but we try to stray away from those. So a controlled experiment has these things. It has an independent variable, okay? So independent starts with I. So the scientist, I am the scientist. I am changing this variable. The dependent variable is the data that is collected. So data dependent variable, okay? So constants are going to be variables that remain the same throughout all trials. We also call those controlled variables. Constant and controlled variables are the same. A control group is different. That is a group that does not have any of the independent variable added. So you can say control group is no independent variable added. So this is the group that you're comparing to see if there is a change. We also call the control group a placebo. So if you're trying to, experiment with a novel drug and you're trying to see if it works, think like a new type of medication. You want to give one group a placebo to see if the medicine actually works, and the other group the actual medications with the active ingredients in it. All right, so another way to write a hypothesis, if your whatever you wrote for your independent variable is first, so if independent variable, whatever that is, then the dependent variable will happen because. So an example is, if I feed my dog bacon every day, his weight will increase because bacon has a high fat content. So the independent variable is going to be the feeding the dog bacon every day, and the dependent variable is going to be the weight increase. And we can measure weight increase on a scale. So that's a numerical value that we can record. So that's going to be a dependent variable. Okay. So we want to test the effect of temperature on plant growth. So what will be the dependent variable, independent variable? What are some good constants and good control? So if I were you, I would pause and I would write down what you think these are. And then, check with somebody that check with me, whatever you got to do. Data collection is always typically in a data table. So this is a data table. This isn't a graph. A graph is a picture of the data. Okay, so this is a data table. So you have qualitative versus quantitative data. There's an N in quantitative data, quantitative, so we say that's numerical data. So we have plant groups 1, 2, 3, 4, 5, 6, 7. The pH of the soil. pH is how acidic or basic the soil is. And the average plant growth in centimeters. All of those things are considered quantitative data or numerical. Qualitative data uses your 5 senses to describe something, like colors, textures, smells, okay? Those are typically opinion or inferences based on what you see, smell, taste, hear, etc. Not typically very reliable data. So we typically use quantitative data to record measurements and, do good science, we'll say. Then here is the graph that somebody graphed to represent data, okay? So a good graph has the following: the title, where you put the dependent variable first versus the independent variable, okay? So, or y versus x. You have the x-axis at the bottom. In this case, it is something. Time. Yeah, in hours. So time is typically an x-axis variable. So it's typically on the x-axis at the bottom. And that's going to be typically your independent variable. The y is the left side vertical axis. That's going to be the y-axis. That's going to be the dependent variable. And it looks like everything's nicely spaced. Everything looks good. So that looks like a good graph to me. And the title is appropriate. Step 5, you analyze the data that you've collected. You graph it. You figure out what's important, what's going on. You summarize it, state your observations, draw connections and inferences. And then you conclude. So you make inferences from that observation. So observation is facts from one of the 5 senses, and the inference is a thought or opinion based on that. These conclusions can become theories, which are proven by hypotheses, but the experiment would have to be repeated many, 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 many times, way more than Fremd High School can provide. Okay, so here's an example of asking a question. So the start of the scientific process here. So how do organisms come about? Forming a hypothesis. Some people thought that spontaneous generation of individuals is where life happened, and it came from non-living matter. So this is just like essentially like looking at an example of the scientific process. Okay, so people propose different hypotheses. Then they, figure out an experiment. There has to be a control group with no independent variable added, and a experimental group where you do have the independent variable added, and then you record data. That data is in the form of the dependent variable. Okay, So then this is an experiment about maggots and how they form and where they come from. All right, so just an example here. They analyzed, they conclude, and then they can either test again or modify their hypothesis or whatever they got to do. Okay, so this is a little example of the scientific process we call the scientific method.